Okay, we're back. This is Techmath2. We're looking at 2.8, 2.9, and 2.10 in the red book. So we're on 2.8 is again, now I don't want to, when I say this is pretty easy, I don't mean this chapter 2 is pretty easy. Chapter 2 is tough. It's not an easy, these aren't easy problems. These are some of the toughest problems we're going to see this semester, and they happen at chapter 2. So, so don't take it when I say this is easy as I think it's really simple or anything. I think it's quite complicated, all right? This particular problem isn't that involved, and so that's what I mean when I say this one is easy. This one, they just want the negative version of the angle. So they're basically trying to tell you, look, I could go this way and say 200, or I could go this way and say, all right, if I take 360 away from 200, basically, subtract those two, but that doesn't make sense in your head, so you probably subtract 200 from 360. You'd say 0, 6, 1, and then say negative 160, because it's not going the correct direction. Remember, it starts at the positive x-axis and goes counterclockwise, and that gives it a positive. If you're going clockwise, you have to put a negative on it. So that's negative 160. And you just do the same thing. If you want to do it in your calculator, you can just say 185 minus 360 to get like the next answer. Oops, that was 2.8. Flipped it. So that would be negative 175, and then 256 minus 360, that would be negative 104 degrees. So you're just going the other way instead of the correct way, the positive, standard position angle. You're going with the negative. Either one of those will work, okay? So this one on 2.9, let's look at 2.9. That is a little more involved. That's number 56. And if you'll remember, to start out to, I did problems like this where we used Pythagorean's theorem, because we know this is 6, this is 5, and this is a 90-degree angle. So we could use Pythagorean's theorem to find the hypotenuse, and then we could use the arctangent to find the angle. I don't want to do that. Let's use our polar coordinates. This is rectangular, and polar, remember, is the angle and that. So let's make our calculator do all of the heavy lifting. So we will go from rectangular to polar, theta of 6, 5, and we will go from rectangular to polar, r, the resultant vector, 6, 5. And we will get the same answers as if we did Pythagorean's theorem and as if we did arctangent, because that's essentially what your calculator is doing. It's just doing it all in one shot. So you go second apse, that's angle. You go down till you see R to arrow P theta, hit enter, and then do 6, 5. That's x, y. So you put in a rectangular coordinate, and it kicked out the polar angle that goes with that. That is 39.81. I think it's likely they're going to tell me to round it to the nearest whole number, so that would be 40 degrees. So this angle is 40 degrees. If you would have done second tangent of opposite over adjacent, 5/6, 5 divided by 6, and then hit enter, it will read out exactly the same thing. Exactly the same thing. All right? Second apse, go down to rectangular to polar r, that's the resultant vector, hit enter, and 6, 5, and hit enter, and that gives you 7.81. And I think they want it to tenths, so 7.8 units. Again, We just used our rectangular to polar conversion. If you would have liked, you could have said 6 squared plus 5 squared. Let's see, that's 36 plus 25, and then taking the square root of 61, which is also 7.81. Okay? All right, cool. Let's do one last problem on 210. Vectors on the axis. Oh, okay. So look at 68. It's a quadrantal angle, so you don't really have to worry too much on this one. So number 68, look at what we have going on here. It's on 270 degrees, straight down, and so it's 0, negative 3.75. And they have it marked OM. So look, they said, what's the horizontal component? Now, when they ask for the horizontal component, that's just a fancy way of asking for x. Horizontal component is the x coordinate, the x. So this could just as easily, instead of saying following the horizontal component, they could just say, what's x? And that's 0, okay? Next thing, find the vertical component. Just a fancy schmancy way of saying y, the y coordinate. So the vertical component is negative 3.75. C. The length is blank units. Okay, well, that's how long. They just wanted to know the length. So that would be like the absolute value of, in this case, the y. So that's, the actual length is just 3.75. And then D is the direction is either, it depends on how you wanted to describe it. You could say, most of us would say the direction is 270 degrees. But it would also be acceptable to say negative 90 degrees because you're describing the same thing. This way it's negative 90 degrees. Going around the proper way, it's 270 degrees. Usually we describe it in the proper way, 270 degrees. The reason that they're looking at the negative 90 degrees is because physics people get their hands on this and they want their vectors always to be with an angle less than 180 on it. And so that's why I'm showing you the negative 90. Normally in math, we stick with the 270. Okie dokie. All right. So that was 2.8 through 2.10.